Hello, everyone. Thank you for joining me this morning. I'm quite excited to present to all of you on my presentation, Why Don't Cobots Collaborate? So I kind of want to start off this presentation with maybe setting expectations, which is maybe not a good sign around what do I mean by this title? Well, in this presentation, what I'm not really setting out to explain why don't cobots collaborate. In fact, I think I'm raising more questions than I'm answering. But I really want to just get this discussion going on about why is it, especially in industry, we don't always see very high levels of collaboration with cobots, which I guess is a bit of a contradiction to the name collaborative robot. I'm Dr. Marc Carmichael from UTS in the Robotics Institute and member of the Australian Cobotics Centre and a CI in Program 2, which I'll be talking a bit about towards the end of this presentation. I think this presentation complements a recent ACC presentation by Mats, Michelle and Chris a couple of weeks ago, talking about cobots, what they are, how they fit into kind of the industry of today, and a little bit about tomorrow. I guess this complements that presentation, thinking about, well, what's the sort of, what are maybe the untapped potential of cobots, especially when it comes to collaboration with humans. Okay, so let's just jump straight in. So if you go online and you search for robot and cobot, these are the kind of images you'll find, right? So you'll see a traditional industrial robot. Often it's a big, heavy robot, typically behind a cage, and very rarely will you actually see a human standing within proximity to these large industrial robots, and for obvious reasons. But we contrast that to a collaborative robot, and pretty much every image you see, especially every marketing image, you have a human in the background or a human that's physically contacting the robot. And that's because really the differentiating factor between robots and cobots is this ability to be able to have cobots working in proximity, in interaction, even close collaboration with humans. So that's the defining factor between the two. So more specifically, thinking about industrial robots. Well, what are industrial robots kind of designed or intended for? Well, traditionally, robotics has always been about, maximum performance, trying to design these robots so that high speeds, high payload capacities, increased accuracy, repeatability, to really be able to maximize the performance when you've got a production line that's doing assembly tasks or welding or any other process, trying to maximize throughput, try to maximize productivity. And unfortunately, the design concepts that allow industrial robots to have these high levels of performance are also often what make them not very safe, right? So big, heavy robots moving around, lots of kinetic energy. For those reasons, they're generally kept isolated from humans. But these robots are very well suited for these repetitive, very predictable environments where the robot can be doing the same task over and over and over again. Generally, though, these robots are quite expensive, not necessarily just the robot itself, but also all of the peripheral equipment. So the cages, the other safety equipment, interlocks, other things that need to be put into place, as well as just the general space requirements. So they take up a lot of space on a factory floor. If we contrast this with collaborative robots, well, they take a very different approach to how these robots are manufactured, how they're designed, and their intended use case. So generally, they have a very lightweight construction. They have inbuilt force sensing capabilities and mechanisms in place that deliberately limit the performance to some degree. So they limit the speed, they limit the force or the power that the cobot is able to actuate. And complying to the ISO technical specifications 15066. But this allows these cobots to be used in close proximity to humans. We kind of mitigate the risk to an appropriate level. And cobots are also maybe another differentiating factor to industrial robots. They're designed to be relatively easy to use. So when we look at what a cobot is or how you interface with a cobot, often you'll have an interface that looks very much like a tablet, right? Like a touchscreen tablet. That might be how you program the robot, very user-friendly. Some programming skill is typically required, but it's very easy to train someone up to be able to commission a cobot, set it up to do, let's say, a machine tending task, which really does reduce the barrier for entry for individuals and for businesses to adopt these technologies, which is really fantastic. And this makes cobots really well suited for more agile use cases, where we might be not just setting up a cobot in one environment doing the same task over and over again. We can deploy and redeploy a cobot to do lots of different tasks on a factory floor. And because the cobots don't necessarily need a physical cage, they're often physically smaller. They don't need a large footing to be mounted onto the floor. That means that they can take up less space and generally can be less expensive. So that's kind of the major differences between a robot and a cobot. But something I'm sort of been thinking about a lot lately is how many cobots actually do collaborate. And what I've been sort of finding is not that many, at least in my experience. Recently, I was involved in a project where we're developing guidelines for the safe deployment of cobots in Australian businesses. And a lot of the feedback that we were getting from integrators and from end users is that they were using cobots very much like what this video is depicting here, where it's the cobot is being used like an industrial robot, but without a cage, maybe is the simplest way to put it. And this is quite interesting. This really kind of goes maybe against the collaborative nature, or at least the collaborative name of cobots. I mean, this is, I love this video. I think it's just a nice example of this common use case. We've got a cobot. Actually, we've got a couple of cobots in this cell, and they're doing a packaging task. And we can see that there is a level of interaction between the human and the cobot system. The human is loading items into the workplace. The cobots are manipulating them, packing boxes, putting the items into the box. And then the human is at the other end to take that out. But I could definitely imagine this exact process being done with an industrial robot. Like, you could imagine swapping the cobots for an industrial robot, having a physical cage around the system, but still having the human loading the items in a small opening in the cage and then collecting the packaged goods out the other end. And so really, this kind of approach is like using it's like an industrial robot without a cage. And I'm not the only one that's been observing this. I was doing a bit of research into whether, is it just my anecdotal evidence that I've been hearing a lot about this. There has been some recent works, in particular by Michaelis in 2020, who has a really great paper looking specifically at this concept of cobots just being uncaged robots. And they had a relatively small user group, 9 participants, but all of them were using cobots to this kind of level of interaction, where the human is really just responsible for loading items into the environment and taking the processed items out. So I want to make something clear. I'm not bad-mouthing this approach to collaborative robots at all. I actually think this is really fantastic. Like this solves an immediate problem for industry today. Being able to have an industrial robot without a cage has many, many benefits. I talked about less costs, no footing requirements, or a smaller footprint requirement. The ability to easily set up, set down, redeploy cobots can lead to greater return on investment, especially for smaller companies that are just dipping their toes into automation. And the easier programming can really lower the bar for the adoption of this technology. But what I've been thinking about a lot recently is, well, what are we missing out on? Or are we missing out on anything? What are the potential gains that are being left on the table by not pursuing higher, more complex forms of collaboration between humans and cobots? And what are the challenges that are stopping this potential to be realized? And that's what I'm summarizing in this presentation today. And I hope to end the presentation with a bit of discussion with everyone here about maybe some of these challenges and maybe some opportunities as well. Okay, so before I go any further, I maybe should actually define what I mean by collaboration. And in fact, just answering the question, what is a cobot, is quite a challenging question. Cobot can mean different things to different people and to different industries. But there has been a bit of a convergence on what the definitions or the distinctions between levels of interaction and collaboration are. So here's a particularly good example from a recent publication of ours, adapted from COP in 2021. And so often the terms cell, coexistence, cooperation, and collaboration are used, or alternatively, I've also seen them numbered levels 0 through to 3, which maybe is a little bit more clearer on the hierarchy. I won't talk about level 0 because that's our traditional industrial robot, kind of human robot paradigm where humans and robots are just kept completely isolated from each other. Starting with level 1, there's the coexistence paradigm where we have a cobot set up in an environment, no cage, so the human is able to get close to the cobot, but we have some kind of mechanism in place, usually some sensor that can detect when a worker does get within a certain proximity of the cobot, and the cobot can then react accordingly. So this is sometimes called the utilization of a safety rated monitored stop, or also sometimes speed separation monitoring, where we have the cobot reacting to the presence of a human. And in Matt's presentation a few weeks ago, I think he went into this really well, talking about the benefits of this, where you can have a cobot that acts much like an industrial robot 95% of the time, where when there's no human that's within reach of the robot, so they could be in any kind of danger, the robot can be running at maximum capacity, really maximizing the utilization of it. But in the small number of times where a human does need to come into the work cell, then the cobot can slow down and stop. So this is a very nice paradigm. And you can see that it's relatively straightforward. There are sensing technologies that exist to implement this. So it's really understandable why this is very, very common and maybe the most popular form of human robot collaboration with cobots today. So if you go up another level to what is sometimes called cooperation, this is the idea of humans and cobots are sharing the same physical space, but there's more influence on each other. So one party influences the other in a more sophisticated way. There may be different or additional modalities of interaction. So using force input, speech, gestures, other forms of interaction that allow the worker to directly adapt the behavior of the cobot. And here's an example video that it's a little old now, from 2015, but I just like the novelty of this particular video. They're doing a co-soldering task where the cobot is supporting the workpiece. And I'm not sure if you went through it kind of quick, but the worker is actually using their legs as a kind of joystick input to the robot to manipulate the workpiece. So it's kind of, I just think that's kind of cool. But this shows, the potential of this more high level form of collaboration where the two parties are sort of influencing each other to get to jointly perform this task. And if we ramp it all the way up to level 3, so this is what many call sort of true or high level collaboration between humans and robots. I think this is what we imagine the future of industry might be, right? You have workers and cobots working side by side. The cobot system is smart. It's able to see what the workers are doing. It's able to understand the steps that they're taking and to intervene with actions that are the most appropriate at that time. Just like a good worker would interact with another worker, being able to provide support, hand them a tool, hand them a widget, and together this system is able to coordinate, synchronize to maximize productivity. So this is quite a good example of that. A recent paper, well, a year old now, where they created this whole framework of using the system's able to perceive what the worker is doing. The cobot is then able to intervene and improve the workflow. So I think this is kind of the dream. This is the end goal for many robotics researchers, especially in human robot collaboration. How much benefit can we actually get out of these higher levels of collaboration? Well, there are not a huge amount of studies on this. Many of them don't leave the lab, but there are definitely gains to be made by utilizing higher forms of human robot collaboration. So in this example that I just showed, the researchers were able to demonstrate in that a box assembly task, a measured reduction in their experiments, sort of time to completion of that assembly of around 6%. So that's not a huge number. But the authors do mention a lot of the challenges that they were facing in terms of the robotic system being able to correctly perceive and identify the particular actions that the worker was making. And because of mischaracterization of what the human was doing, sometimes the worker had to intervene and actually have a manual input into the task. but they were able to simulate what would happen if those instances of poor performance on the cobots perception end were not present, and they estimate that a saving of up to 20% would have been realistic. And 20%, that's a pretty substantial saving for these sorts of assembly processes. So I think the takeaway message here is there are real gains to be made by having robots and humans working together. Just like you would have, a good human team of your human workers working together can really maximize productivity. The same can be achieved for humans and robots working together too. But as I mentioned, many of the demonstrations that we see of these higher level forms of collaboration, they're all in the lab. they're mostly in the lab anyway. They're kind of in universities. They're very structured tasks with top-down views of cameras, and you can see in that example the human is wearing a device on their arm. So it's a very structured approach to solving this problem, which then I think begs the questions: what do we need to do to make this something which is realistically deployable for industry? What are the challenges we need to overcome? So that leads me to this quote, which I particularly liked from Michaelis and co-authors, where they were looking at this phenomenon of how in industry these lower levels of collaboration are by far the most common. And they talked about how while cobots are created with the capacity for collaborative work, it's really up to the entire system to be able to accommodate these higher levels of interaction. Or kind of simply put, cobots are simply traditional robots without a cage, unless engineers deliberately design for human-robot collaboration. And that's so I think I see that as a challenge. I think that's our job here as robotics researchers. Okay, so how to address this gap, how to fill this gap, how to enable higher levels of collaboration to leave the university lab and to get it into industry? Well, there's kind of two approaches. One is to look at the workplace itself and take a more of a workplace-centric approach to look at how workplaces can best leverage the collaborative capabilities of cobots. So this could be training workers to better understand how cobots can collaborate. What are their strengths? What are their weaknesses? Being able to even design existing workflows to leverage the collaborative capabilities of cobots even better, right? So that might require some rethinking, redesign of existing processes. But if workplaces understand that there are benefits to be had, or even better, if we can show that those benefits are entirely reasonable, then I think that'll go a long way to bridging that gap from the lab to the field. But then there's also more engineering-focused challenges. How can we actually make robotic technology, cobotic technology, better suited to filling that void, right? How can we create cobots that can collaborate in a generalizable way, have intuitive interaction paradigms, make them even easier to program, not just through a touch interface, something that looks like an iPad, but actually just programming directly through physical interaction, just like you would teach a junior or a new member of your staff coming in. How would you teach them to do an assembly task? You might just literally grab them by the hand and show them the ropes. Can we train or program robots in the same way? Like the previous work was mentioning, there are limitations in terms of robust methods for perceiving the actions of workers and how to contribute to the tasks that workers are performing. So a lot of engineering challenges that still exist. I'm more focused today on these engineering-centric challenges, but I do want to call out to the other ACC programs, especially Program 5, the Human Robot Workforce, and Program 3 as well, Design and Socio-Technical Robotic Systems. I think there's a really good opportunity here to collaborate where coming both from the engineering-centric challenges and the workplace-centric challenges and kind of meeting in the middle. Okay. Now I don't have too much time, and And there are so many challenges when it comes to human-robot collaboration. I'm only going to touch on a few of them, primarily physical interaction, since that's my research background, is how humans and robots physically interact. So I'll go through that a little bit. I'll also talk a little bit about intention recognition, the challenges with that, and some work that we're looking to do, and also learning by demonstration. But this is such a large problem. I'm not kidding myself. I'm not giving you the solutions today. So here's an example of a challenge that exists when we do have humans and cobots physically interacting together. This is a project where we have a cobot that is doing an industrial blasting task. And if I play that video again, we can see the worker is manipulating. The worker is manipulating a tool using a cobot. And this is the first time that this worker is using this robot, right? We've taken it out of the lab, we've got it on site. And the first thing that happens is the worker moves the robot to its extremity. It goes into a configuration which we call a singular configuration. It's in a singularity. And the robot stops working, and the worker lets go and has a confused look on their face. And in hindsight, this was completely obvious that this would happen, but it caught us a little bit off guard, because it's like, well, okay, we've been using this robot in the lab and it's been completely fine. And the reason for this is, we're roboticists. We were using the robot kind of maybe subconsciously knowing that we shouldn't take the robot to its extremity. We shouldn't put it into a singular configuration. But of course, you've got someone coming in, never used a robot before. We need to develop interaction schemes that are robust to all these use cases, all these edge cases, and are able to convey information about the limitations of the cobot back to the worker in an intuitive way. And you'll hear me say the word intuitive a lot in this presentation. Sorry about that. But it needs to be intuitive, because we don't want to, one option could be to have some kind of visual indicator that's on the end effector of the robot, providing, a red light flashes when the worker's doing the wrong thing, and a green light flashes when they're doing the right thing. That may work, but it adds more, it requires concentration, and there's a learning curve around that. We want to minimize cognitive load. We want to have an interaction where you don't even have to think about it. You just grab the end effector, move it like you would normally. So based on these findings, we actually found that there are these existing techniques for controlling robots, avoiding singularities, avoiding collisions, avoiding these sorts of non-ideal configurations of the robot. These exist and have existed for a long time in robotics, but there was very little work that was examining how these techniques are perceived by humans who are then controlling the robots during physical interaction. And we actually found, by implementing some of the most common methods, that one of the most common is called damped least squares, where the robot kind of slows down and stops before it reaches the singularity. That technically works, but when you are a human that's interacting with the robot, it feels bad. It just feels like the robot is getting stuck in the mud, is the way that I describe it. Kind of the robot slows down, gets stuck, and then you try to move away from the singularity, and it just doesn't work very well. It's not intuitive at all. And so we developed a framework where it was actually just a very minor tweak to what existing frameworks were doing, but we designed it from the beginning to consider how the user might react to the sensation of the damping, and have parameters that we can tune to change that to what the preferences of the user might be. And so you can see in the video that led to a very robust controller, which was very intuitive. And we actually did get the chance to test this on people. So here's some additional work on it. Actually, here's another example of that same interaction scheme. If I let this video play for a second. So I'm using these two elastic bands to apply forces in a way that you can visualize it on video. And so I move the robot to the extreme of the workspace, and you can see when I pull on the blue band, there's this hesitation of the cobot wanting to come back into the workspace. Now that hesitation, you can imagine, doesn't feel very good as you're using the robot, because you just want to move the tool around. You don't want to have to, you don't want the robot to, you apply a force and the robot doesn't move. And that was inherent in the traditional methods of singularity handling that were used for decades, but without a human in the loop. And again, by considering how a human might react to this, we did some very simple modifications to this approach and found that it significantly improved the user experience of the robot. So here you can see that the robot is a lot more reactive to going out of that singular configuration. And then following this, we did some surveys with experts and non-experts about whether they preferred our approach, and by far it was preferred over the traditional methods. So I think the real takeaway from that is there are lots of existing methods, but many of them we need to rethink as soon as we have a human in the loop, a human that's now collaborating with the robot. Okay, so we've made a lot of progress with physical human-robot interaction, and we've got ways of controlling the robot. So this then leads me to this concept of learning by demonstration. Now, I love this idea where rather than having to write some software to program how a robot or how a cobot needs to do a task, well, why don't we just literally grab the robot and move it around? You saw in the previous videos, we can do that quite robustly. We can grab the end effector, we can move it around, we can push a button to say you move here, then move the robot, push another button here. We can program this. And many cobots actually out of the box have this sort of functionality built in. But I wanted to include this work. This is recent work by Fred, Victor, Teresa, and Jochen at the ACC, which was published, I think, ICRA just recently. Sort of taking this to the next level, this idea of programming robots by demonstration, by looking at, well, what happens when you actually don't have a robot? How can you program a cobot when you don't have the cobot available? Or maybe you do have a cobot, but that cobot is actually currently being used in your production, right? Especially if you're a smaller business, a small company, and you might only have one cobot and it's being used, pretty much every day. You might not have the time, or it might not be free for you to actually program it via demonstration. So this really interesting work was looking at using a kind of replica end effector, which is tracked in 3D space, to do the demonstrations without a cobot physically being present. But then obviously without the cobot being present, there's the potential that the motions you demonstrate are not feasible, but because the robot might have a limited workspace, it might collide with objects in the environment, and those constraints, which normally would be naturally considered when the physical cobot is there, well, when it's not there, you have the freedom to violate those constraints. And so this software was developing a framework that allows the user to visualize, as we can see on the screen, to visualize those constraints such as collisions and take them into account during the demonstration process. So yeah, some very cool work there. Okay, so, and another challenge about human-robot collaboration I want to touch on is intention recognition. And I touched on this in the earlier videos about how there's a lot of potential to maximize effectiveness or maximize productivity of humans and robots working together, but this can fail very quickly if the robot is unable to understand the intentions of the human, of the human collaborator. And there are ways around this, but there are kind of intrinsic pros and cons, which I wanted to talk about a little bit. So I think one of the simplest approaches to having a robot understand a coworker's intentions during a task is to just tell the robot, right? Just to say to the robot, do this, do that, move left, move up, move down. And this is the video shown before where the legs of the worker are being used, or the feet in this case, are a kind of proxy for a joystick input. Maybe that's one way to think about it. And so you can imagine this is pretty straightforward. You just have to map these different inputs to a certain response of the cobot. And this would allow you to be able to, free your arms up to do this soldering task in this video, but then use your feet to then move additional degrees of freedom in the task. So this seems like a very robust way to do it, very logical way to do it. And there's lots of options for these inputs as well. So voice commands, gestures, biosignals, direct force input. We have quite a lot of options in terms of which modalities do we use. But we need to make sure that we choose the appropriate modality, because Many modalities are probably not very intuitive for certain applications. I think many just don't suit certain workplaces very well. I kind of imagine a scenario where you've got dozens of cobots on a production line, and they're all reacting to the voice commands of the workers there. And every second, a robot is saying, "Hey, cobot, do this. Hey, cobot, do that." That just sounds like a terrible place to work in. Everyone's saying, "Hey, cobot," all the time. So I can't imagine voice interactions being a very appropriate modality for that scenario. And if anyone has tried to use, your Google Home Assistant or Siri or Amazon Alexa, and it doesn't work very well, and you have to repeat the thing 3 or 4 times, like that just sounds like a frustrating time. So there's a lot of work that needs to be done on improving those input modalities and finding the right combination of modalities. But this direct form of conveying your intention to a robot might not be suitable as well for the fact that you have to think about it, right? I have to think about saying to the cobot, "I want you to move up. I want you to move left." I have to, it takes cognitive effort to then tell the cobot that's what you want. What about approaches where we don't need to do that? What if there was a way for the cobot to just literally read your mind and know what you're thinking and react accordingly? So as crazy as this sounds, there is actually work that's looking into this. A recent paper of ours at UTS was looking at using brainwaves as a measure of how expected the interaction of a cobot with a human is in real time as well, and using that as a measure of whether the cobot is doing what's expected by the user, or whether the robot does something unexpected, which could be used as a measure of, okay, maybe I've done the wrong thing here. And you could imagine this feedback being used in some kind of deep reinforcement learning architecture, where over time, the robot can learn a policy so that it's always doing what the user expects it to do. So this is kind of science fiction sort of stuff. It seems like that should be pretty far off, but it is happening today. But obviously, there are some impracticalities when it comes to using EEG. You can see in the photos our researcher there. He's using a headset with dozens of electrodes. Obviously, that's not going to be very practical at all when it comes to most workplaces, strapping on electrodes every time you turn up to work. But even any kind of wearable might be a bit of a limitation. It's very common for researchers in the lab to use like a smartwatch or an inertial measurement unit, an IMU, mounted onto the hand or onto the arm, and to use measured accelerations as an input to the cobot system. But even those take, you have to wear a device. That is something which is, I mean, it's annoying, but might actually not be allowed depending on the workplace if there are very tight regulations about the devices that are allowed into certain areas. So maybe a nice intermediate approach is something a bit like this video here that's using what's called action sequence recognition. So this is using a sequence of images from a camera that is then trying to classify the specific actions that the worker is taking so that then the cobot can intervene appropriately. So this is a cool little video. I like this one, doing some IKEA furniture assembly, a flat pack kind of assembly. And the cobot is, well, the system, which includes the cobot, but the camera as well, is able to identify the actions of the worker step by step and then intervene when needed. You can see it can do real-time handovers. It's in this dynamic scene. So yeah, we can see it's grabbing the legs of the table. The worker is doing the assembly. Yeah, hands the worker the last leg, and then hands them a cup of tea because they've done the task. So great. So I really like this approach towards. I think this is a good intermediate. It's not direct input. You don't have to necessarily say to the robot what you want it to do every time step. So it's a bit more intuitive, although I think there are still concerns around, let's say, putting dozens of cameras into the environment. I think that's a real problem which we need to address if we want to use those sorts of methods going forward. Okay, so I'm conscious of the time, but I wanted to end with that was a lot of examples of maybe what's potentially possible and some discussion around the challenges. I've given very few solutions. so in some ways, this has been a very depressing talk, but I do want to talk about Program 2 in the Australian Cobotics Centre, and some of the things that we're looking to do, which may address or will address some of these challenges. So we've got 3 primary projects, which I'll go over quickly. Project 2.1, robotic intention visualization. This is really cool because if we have a robot that's working with a human, a human working with another human, we have body language. We're able to kind of anticipate what my fellow human is going to do. I can read their body language. I can look at their face. Robots don't really have those cues. And so how can we convey the intention of a robot to a human worker? And that's what Project 2.1 is looking at. There's a really nice paper recently written by Stina, Jared, and Marcus, not necessarily on this intent visualization, but related in the sense on how do you visualize or how do you illustrate motions of robots. So I think this will naturally lead into techniques that we can use for intention visualization of cobots. Project 2.2, so this is with James, a PhD student, looking into a human-robot interaction prototyping toolkit. I'm really excited about this one because I started off the talk about how we often don't see higher levels of collaboration leave the lab and get into the field or into industry, onto the factory floor. I think a prototyping toolkit like this will help to bridge that gap because it'll allow businesses to quickly and cheaply prototype how higher levels of human-robot collaboration could work, or work for them, I should say. I'm also very interested because I think this not only helps the end users, I think it helps the engineers as well, because then we can see how those end users want to use the cobots in their facility, and that might give us ideas on how, what software should we be writing, what modality should we be exploring. And so I think it's actually a bit of a two-way toolkit for both the end user and the engineer. And lastly, we've got Project 2.3. This is multimodal human-robot collaboration, looking at combining physical interaction with other modalities as well to create these frameworks that can improve productivity and improve usability of cobot systems in a very natural and intuitive way. So this is largely led by our PhD student, Lewis, who's done some preliminary work. This was a publication last year on more the physical interaction. Lewis is now looking into that action sequence recognition methods and how to integrate the two together. So it's some exciting work happening right now. Okay, so actually haven't gone that far over time, so that's fantastic. I wanted to end the note on, first say thank you, and I'm happy to take any questions, but what I would actually really love is not necessarily, I'm happy to answer questions, but I would actually love to hear feedback about why people here today think, what are the main challenges for increasing the levels of collaboration in industry, especially if we have members from the public, if we have people from businesses who are thinking about cobots or even are using cobots today. I would love to get examples of what are the barriers to this. Are there obvious problems that you see? Are there concerns around, putting certain sensors in the environment? So maybe we can, if people want to talk now, I'm happy to do that. But there's also a Mentimeter link if you just wanted to, type a few comments in, in the background or even after this presentation. Please feel free. I'd love to get that feedback. Okay, that's it for me. Thank you very much.
Mark, it's Sean here. Great presentation. Thanks so much for really clearly making a distinction of collaborative robots in a way that I think personally I've learned a lot, and it's helped me understand really the distinctions. And as you know, we've been doing a lot of interviews with people in industry and academia and so forth, and I think that they have a very unsophisticated understanding of what a collaborative robot is. So this is super helpful. You sort of put it as a, I'm sure you didn't mean it as a binary, but you put it as, workplace training and skills versus an engineering response. Have you perhaps another way to look at it is from a value creation perspective, in the sense that as you scaffold up from coexistence to cooperation to collaboration, that in many ways we're moving from industry 3 through to industry 4 or 5, right? In the sense that you can start to do much more bespoke kind of operations using the collaborative robot in that true collaboration sense. And I'm wondering if it's another way to look at it is, how does the business model potentially change for the organization in terms of what they're able to produce? So maybe starting to think about it is the different types of value that cobot can create for the organization within the production chain.
Yeah, that's a really good question. What this makes me think of is how glad I am that I'm a member of the ACC. We've got a multidisciplinary team who can look at these other elements, because the truth is, I am not the right person to ask those questions. I mean, I think this is not just a robotics problem. This is technology in general, is that we have engineers who maybe develop these technologies. And I think engineers are often very different people to, say, the end users. They're very different to the people who are running a business, the high-level managers. I would never run a business. I would be absolutely terrible at it. So I think that's where we have to have a lot of collaboration, so that we can feed back those needs of the business, how value can be created, and feed that back down to some technical requirements, which then engineers can develop. So I think that's what's needed. And again, I'm very glad that we've got designers, we've got people with business backgrounds, innovators in the ACC. So I'm hoping we're going to leverage that here.
Great.
Peter.
Hey, Mark, that was a really great talk. Thank you. I got lots of ideas. I'm typing them into Menti. I was recently traveling after ICRA, and I visited Technical University of Munich and had long chats with them there about cobots. And they really actively dislike the term cobotics. They said just the fact that you bought a UR5 and put it in your factory does not mean that you have a collaborative robot. So, that's exactly the same as your message. And they were sort of working to try and come up with more distinct terms for the capabilities of robots. The ability to do force sensing, determine if it's hit somebody. Anyway, they had a much more nuanced idea about that. I sent an email to John. He told me I was overthinking it. I'll send the email to you instead. And happy to have a conversation with you about that. The other thing that came my way was a robotic business analysis podcast, which suggested that the cobotics market was, sort of maybe reaching the peak of a hype cycle. The sort of the energies coming out of the cobotics market, because people aren't getting the value out of them. It's maybe because they just buy it from the shop and expect it's magically collaborative, when actually you've got to do a bit of work, bit of coding still. So there's some input for you.
Yeah, I've heard a similar thing about the peak of the cobot kind of hype train a little bit as well. Maybe from some European colleagues in particular, because usually other countries tend to lead Australia a little bit in terms of the adoption of those sorts of technologies. So they might be at the peak, whereas we're getting to that peak. I'm hoping that Australia could be a little bit different, maybe buck that trend. I think maybe being delayed by the rest of the world could actually be a benefit, because some of the technologies that didn't exist when people had that hype early on might exist by the time that we're at that peak. So we could adopt those technologies.
We can recognize what's holding it back overseas and try and rectify that for the local market.
Even better, we develop those technologies, and that becomes, that's something we can do. And then also Australian manufacturing is very different to those other countries as well. So I think that might allow us to, so the idea of using an industrial, a cobot just as an uncaged industrial robot, I actually think that's very, very valuable in Australia by itself. So even without those higher levels of collaborations, I know that goes against the message I was saying. We should be going for high levels of HRC, but I think there's still a lot of value for Australia. So I'm hoping that is another difference.
Yeah, thanks, Mark.
Great talk, Mark. I've got a question about the kind of workspace versus engineering dilemma, or maybe seeing it as a dilemma in the first place. So this kind of problem came up when I was working in apple picking, actually, so in agriculture, where there was this one potential solution was to kind of restructure orchards, like apple orchards, to facilitate robots, as opposed to having to rely a lot on the autonomy of the robot, the capability of the robot. And so that was kind of not well received by farmers, because they had to put a lot of effort into restructuring their workplaces. So yeah, I'm just wondering what your kind of opinion is in maybe the manufacturing sector on how much effort we should kind of spend or put into either one of those kind of branches. Maybe other opinions on it.
Yeah, I mean, that's the problem, isn't it? Because I mean, in some ways that goes against what a lot of cobot marketing can be. Like, a lot of cobot marketing talked about very agile system. You can drop it into your workplace with very little change to your environment, and you start getting those benefits. You start getting value from it straight away, which I think is true for those lower levels, that sort of level 1 of human robot collaboration, because you saw from the video that it doesn't actually take much. You can have a safety area scanner that slows the cobot down when a human gets too close. And yeah, that is very agile, very minimal change to the workplace, to the workplace setting is needed to facilitate that. But if we're needing to, let's say, put a whole bunch of cameras in the environment to then have a system that can detect the actions of workers, and then have some, deep reinforcement learning running in the background and all that, that's not feasible for, I would say, the vast majority of places for a lot of reasons. Firstly, it seems like a very bespoke solution that needs basically a PhD student dedicated towards achieving that, at least at this stage. I mean, I'm confident in the future there'll be off-the-shelf products that can do many of these things, but for now it seems it's very bespoke. And the other is just around other, like, putting sensors in the environment. This is something I've been thinking about a lot. Like, there's all universities, when they show these capabilities, they have a bunch of real sense cameras. If I was a worker in an environment on my production line, all of a sudden the next day I come in and there's 12 real sense cameras looking at me, I'm not going to like that very much, I think. And so thinking ahead to not just solving the problem, but in solving these problems in a way that will be embraced by end users, by the workers, by the businesses, I think that's a major challenge as well.
Yeah, even you put in all those measures, and then the autonomy improves in a couple of years, and then all that stuff, kind of all the infrastructure becomes useless as well. That's kind of another way to think about it. So
yeah,
or redundant, which is not useless. Redundant.
Interesting times.
Yeah. Cool.
Well, thank you for the questions. The Mentimeter link, I think that stays active for a little while. So if you think, I think this video will go up pretty shortly after, so you could even find the QR code. And if you think of something in a day or two, don't hesitate to go back on Menti and provide your feedback, or shoot me an email directly. That'd be great. Well, I think we're done.